So, with the title Fragrance for Chemists, so fragrance has many aspects. There's the history of fragrance, there's fragrance creation and duplication, there's regulatory issues, there's the fragrance and your emotions, all these different aspects of fragrance. But for this limited time and for this audience, we're going to stick to fragrance just as chemicals and the most technical way of looking at it. So, fragrances are mixtures of chemicals. I mean, that is the ultimate fact of looking at it as a science. So generally, there's small molecules from 5 to 17 carbons. The olfactive threshold means how much has to be in the air of these molecules for you to be able to smell it. Some fragrances, aroma chemicals, are much stronger than others. The biggest fragrance molecule to date in terms of size is Phenylethyl, which has a molecular weight of 284, and it has a very powerful odor threshold. It's important that fragrances be small because they have to be up in the air, and they have to be able to fit into the receptors in your nose. So here's an example of how diverse the chemistry of fragrances are. This is a way of characterizing aroma chemicals, and it was basically the method used by RIFM, that's the fragrance safety people, to prioritize fragrance molecules for testing. So you have all kinds of chemicals, alcohols, esters, aldehydes and ketones, and heterocyclics and acids. They're saturated and unsaturated and cyclic and straight, etc. Down the bottom is an arrow pointing to the reactivity. And that's the chemical reactivity, but it's also the reactivity in terms of safety for human use. So we have a lot of different kinds of chemicals that we are dealing with. So to begin, the simplest ones would be hydrocarbons. And there really aren't a lot of hydrocarbons per se used in fragrance. There's a few of them, cariphyllene, and you can see some of them have rings or open structures or just chains. And the biggest category of fragrance molecules are esters. There's just a lot of esters. Of course, they're very easy to make, and they're also relatively easy to fall apart. So they're unstable at high and low pHs, and they might precipitate in acids. But this is a huge group of aroma chemicals. Small chain esters typically smell like fruits. So things like bananas and apples, pineapples, those characteristic smells are from short chain esters. So here are some examples of these ester structures. Benzyl benzoate, which is a solvent. Citronellyl acetate, which smells like a rosy fruit. Amyl acetate, which is one of those pear apple type fruity notes. Benzyl salicylate, which smells like a floral. And you will notice that, we're following basic chemistry here. So ATE at the end of a chemical name means ester. Then there are the alcohols. You have aliphatics and aromatic alcohols. A common one is phenylethyl alcohol, and this smells like a rose. Now, most fragrances are pretty much oil soluble, have very limited water solubility. But of those that are somewhat slightly water soluble, phenylethyl alcohol is an example. It also has antimicrobial properties. And I note down the bottom when you're reading about fragrances or seeing presentations, sometimes I use the acronym FRM, which simply stands for fragrance raw materials. Another big set of families are the aldehydes and the ketones. So they're very closely related, but in terms of reactivity, the aldehyde with that one hydrogen hanging there instead of another group means that the aldehydes are more reactive or less stable than the corresponding ketones. So here are some examples of ketones, and you will notice, they can be literally just in the middle of a chain. They could be hooked onto a cyclic structure, and they could also be hooked onto an aromatics. So the chemistry of fragrances, you must always keep in mind, is very complicated.